Coming in hot. Coming in hot.
Hello everyone, yeah, welcome to Daily Solutions. So in this video, we have a figure that we want to recreate in AutoCAD. This video is going to be the part one where we accurately fill out the table here using the appropriate coordinate system. So the question goes like, figure one is a geometric object. We have been asked to provide the appropriate absolute, relative, and polar coordinates for figure one, assuming that it traverses anti-clockwise around the object starting from point 10. So what the question is trying to say is you have a point 10 here, and we are trying to get the coordinates for all the points here, assuming we are going in this direction. So you are going from here back to point 10. All right. So before we start, there are a few things we need to take note of. Right. So in AutoCAD, let me go. In AutoCAD, there are some things you need to be aware of. If there's a movement in X that is going to the let me change this, that is going to the left hand side, the convention is minus. Now if it's going to the right hand side, the convention is plus. The same thing too for y. If y is going down distance, the convention is minus, or you subtract. And if it's going up, you add, or it's assumed positive. This is the key thing you should know for now. All right, so let's begin. So you're going to get the point. You first begin with the absolute, then relative, then polar. So let's begin. We have already been given points 10 as 100, 150. Now let's come to point 1. Point 1 is directly below point 10, meaning there's no change in x, meaning the x value is still going to be the same as this. So let's go ahead and write it 100. Now for y is coming down in distance. So it's going to be minus. The distance is 70. So it's going to be 7. So it's going to be 150 minus 70. And that's going to be 80. And that will be the coordinate for y. This 80 is obtained by subtracting 70, this 70 from 150. All right, so let's go on to point 2. For point 2, there is no change in y. It's on the same axis as y, but then there's a change in x, meaning the x value will change, but the y value will be the same as the previous. So you can go ahead and write the y value because it's on the same line. Now for x, we are moving the distance this way. And what's that distance? We have the entire figure to be 180. We have the distance to be 100, so meaning this is 80. Now the coordinates for x will be 100 minus 80 because you are moving in the negative direction. And that's going to be 20. You put in 20. Now let's move on to point 3. For point 3, there is no change in x. It's all on the same line as x, but there's a change in y. So let's write the x first. So x will still stay the same as 20. Now for y is changing by 120. That's the entire distance from this reference point to point 3. That's 120. And it's going down, meaning we are going to subtract. So it's going to be 150 minus 120. And that will give us the coordinates of y for point 3. And that value is going to be 30 for y. So I'll go ahead and write 30. Let me clean this. All right, so now let's proceed. We are point 4. So for point 4, there's both a change in x and a change in y. So let's begin with the x. So taking it relative to this point, we have, if I'm to extend this, we have the whole distance to be 100, or here is 180, meaning this entire distance is 180 minus 100, which is 80. But here is 50, so meaning this distance is 30, right? So we are moving a distance to the left, a distance of 30. So that's going to be 100 minus 30. That's 70. Now for y, we are moving down a distance. We have the entire thing to be 150, and here is 120, meaning from here to this is also 30. Right. So we are moving down a distance of 120 plus 30, that's 150. So that's going to be 150 minus 150. That's going to be 0. So this point to be 0. Mind you, because it's the absolute, we are taking all the points relative to this point. So whether we are moving up or down or left or right, we are taking it relative to this point. All right, so let's move on to point 5. So for point 5, there's a change in x, but y is still on the same line. So y will stay the same as 0. We need to find the coordinate for x. We have already found out that this entire distance is 115. This is 50. This is 30. So the sum of these two will be 80. So 150 minus 80 will be 70, meaning we are moving a distance to the right. That's going to be a plus. So this is going to be 70 plus 100 here. So that will be 170. That will be the coordinate for x. Now for point 6, there's both a change in x and y. Let's do that of x first. So in terms of x, the distance at point 6 is 100 from this direction and is moving to the right. So we are going to add it. So it's going to be 100 plus 100. That will be 200 for x. Now for y, the entire distance is 150. So to this point will be 150 minus 40. That's one thing. Now to find this relative to this, since we are going down, we are going to subtract. So it's going to be 150 minus 110, which will be 40. So that's it for point 6. For point 7, x is going to be the same, since it's on the same axis as that of 6. So x remains the same. Now y is going to change by this distance. Now I'm giving this as 150, this as 110, meaning this is 40. So y is going to change, since it's downwards, it's going to be 150 minus 40, which is going to be 110. And that will be for y. Now for point 8, y stays the same. So you can just write the value of the previous one. X is changing. And let's see how much it's changing. So from this point to here is 60, because the whole thing is 100 and this is 40. So this distance is 60. So 60, since you're moving in the right side, you're going to add it. So 60 plus 100, that's going to be 160. I'll go ahead and write 160 for the x. Now for point 9, x is still on the same axis as 8. So it's going to be the same, 160. But y is going to change. y is going to change in this direction. Now for y, it's on the same axis as point 10. As you can see, it's on the same axis. So y is still going to be the same 150 plus 0, which is 150. So I'll go ahead and write 150. Now coming back to point 10, there is no change in x, there's no change in y, it's still the same. So it will still be 100, comma 150. So now we have been able to do that of the absolute. Now let's move on to the relative. Now in relative, when you're specifying it, you need to include the at sign to show that it's a relative coordinate you are trying to specify. And what the relative means is that each point is specified based on the previous point. So for example, we have our point 10 here. Point 1 will be specified based on this point. Point 2 will be specified based on 1. Instead of the absolute where everything is specified based on this, in relative, the next point is specified using the previous point. Let me clean what we already did. Let's do that of the relative. All right, so let's begin. So for point 1, we are taking this point relative to this point. Right. So we have our at sign. So you check, is there any change in x? Is there any change in y? For this, there's no change in x. So x will be 0. For this, there's a change in y, which is 70, but it's moving downwards. So it's going to be negative. We have negative 70. Now let's move on to point 2. For point 2, we ask ourselves, is there a change in x? Yes, there's a change in x. And the change is 80 because it's going to be 180 minus 100 is 80. But since you are moving to the left, it's going to be negative. So it will be minus 80. There's no change in y for point 2. So it's going to be 0. Let's go to point 3. For point 3, is there a change in x? No, there's no change in x. It's on the same line. So x is 0. But there's a change in y. And y is changing by 150, 120, sorry, 120 minus 70, which is 50. But it's moving downwards, so it's going to be negative. So it will be minus 50. Now let's move on to point 4. For point 4, there's a change both in x and y. So let's see. So relative to this point, so let's start with the x first. So x is moving to this side, which is plus a distance of 50. So that's going to be positive. So that'll be 50. Now for y is moving down a distance of 150 minus 120, which is 30. But since it's coming down, it's negative 4.4. So it's going to be minus 30. Let's come to point 5. For point 5, let's check if there's any change in x. Yes, there's a change in x. And by how much is it changing? The entire distance is 150. This is 50, so meaning it's changing by 100, but then it's going on the right side, so it is positive. So it's going to be positive 100. Now there's no change in y, so y will be 0. Let's go to point 6. For point 6, there's a change in x, there's a change in y. Let's first check the change in x. So x is changing by 180 minus 50, which is 30, but then we are moving to the right. So it's positive. So it's going to be at 30. Then for y, there's also a change in y. It's going upwards, meaning it's a positive. By distance of 40, it's going to be positive 40. Let's go to point 7. For point 7, let's check. Is there a change in x? No, there's no change in x because it's the same, it's on the same line as 6. So x is going to be 0. Now, we are moving up a distance in the positive direction. So we expand the value to positive. The distance is going to be 100 minus 40. Sorry, 110 minus 40. And that's going to be 17. So we are moving up, we are changing up a distance of 17. And since we are moving up, it's going to be positive. So this will be 17. Now let's move on to point 8. There's no change in y because it's on the same direction. So it's on the same line as point 7. So our y, you can write 0. Now for x, we are going a distance of 40, which is to the left. So meaning it's going to be a negative value. So our value of x will be minus 40. Now let's do 4.9. 4.9, the x value doesn't change because we are in the same direction as x. But then y is changing. Let me go ahead and write the x first. So x is staying the same, so it's 0. But y is changing by a distance of 150 minus 110, which is 40. But then it's moving up in the positive direction. So that becomes a positive number. The distance becomes 40. And this 40 is obtained by subtracting 110 from 150, which will give you 40, the positive direction. Now, coming back to point 10. Now, relative to point 9, there's no change in x. It's still on the same line as x. Sorry, there's a change in x, I'm sorry. There's no change in y. It's still on the same line as y. So our y value is 0. Now, our x is 60, but then it's moving to the left, which is a minus sign. So meaning the value is going to be minus 60. So that's it for the relative coordinate system. So one key thing to keep in mind is each point is referenced based on the previous point. So in specify the coordinates for the next one, we check how x and y changes and the magnitude by which they change. And based on the direction, whether it's positive, sorry, based on the direction, whether it's going down, which is negative, or it's coming up, which is positive, or left or right, which is negative and positive respectively, you know which value to put in, whether it's going to be a positive number or a negative number, based on the direction. Now let's do the last one for the polar. I'll go ahead and clear my screen so we have space to do a few calculations. So the polar coordinates usually used when we want accurate and precise measurements in terms of angles. In AutoCAD, you can use the polar tracking to specify angles, but then it's not every angle you have in the polar tracking. It's the regular angles like 60, 30, 90, 45. What if you want to specify an angle of, let's say, 23.5? You have to use the polar coordinate. And the polar coordinate is specified using the magnitude and the angle. And these are the key things you need to keep in mind. I will draw at the bottom. The key things you need to keep in mind. So for polar, you have a coordinate system. And it moves in the anti-clockwise direction. So you have these points to be 0, then 90, then 180, then 270. So this is going to be very key in specifying the polar coordinates. I'm going to draw it somewhere here so that you can easily reference it. So we have 0, 90, 180, then 270. With the polar coordinate system also, it's similar to the relative. That is, the next point is specified using the previous point. And it's going to be by magnitude and direction. So let's begin. Similar to the relative, we need to include the at sign. So let's see. So for point 1, what is the magnitude? The magnitude is 70. So we'll go ahead and write 70. Then we have this less than sign to show the angle. Then we are moving in this direction, which is 270. So you go ahead and write 270. Okay, now let's move on to point 2. So for point 2, the magnitude in this direction is going to be 180 minus 100, which is 80. So at 80. And the angle is 180 because you're moving in this direction. Is 180. For the polar, you don't need to worry about negative or positive. You're just picking the magnitude and the direction. Right, so for point 3, you're moving from here to here. The magnitude is 120 minus 70. And that's 50. And the direction or the angle is 270 in this direction. So we go ahead and write that one. 50, 270. Now for point 4, we have to do a calculation to determine the magnitude. So the magnitude in this case, let's specify it as x. Let me change to it so that we know that's the calculation part. This one. So this is our x. We'll go ahead and complete the triangle here. We are trying to find this angle. Let's call this θ1. We know this distance. We can find this distance. We also know this distance. This distance is 150 minus 20, which is 30. We know this to be 50. So using the Pythagoras theorem, we have x squared is 30 squared plus 50 squared. So when you sum it up, let's see, 30 squared plus 50 squared. That's going to be 3,400. Now taking the square root of that will give us a magnitude of 58.3. We are taking it to 4 decimal points. 58.3095. So that's it for the magnitude here. Next, we need to find the angle. Now we know, let me clean this. All right, so we are finding the angle. So we know the opposite sign. We know the adjacent 30. So you can use tan of θ1. We can equate it to opposite, which is 50 over the adjacent, which is 30. So the θ1 will be the tan inverse of 50 divided by 30. Or to make things easier, 5 divided by 3. So our theta 1 will be yeah. So our theta 1 is going to be 59.0 59.036. But mind you, let me complete this. So you have this to be a coordinate system. So in terms of the angle, we have already found the magnitude to be 58.03, sorry, 58.3095. Now the angle is going to be 270 plus theta 1. So the actual angle is going to be 59.0363 plus 270. And that's going to be 2630922. That's going to be 329.03. So let's fill it out. So our magnitude in this case is 58 58.3095. And our angle is 329.063 degrees. So that's it for point 4. So let's move on. So for point 5, we are moving a distance of 150 minus 50, that's 100. So at 100, and the angle in this case is 0 degrees. Now for point 6, we will need to do another calculation. So let me clear the space. All right, so let's assume here to be our theta 2. We have this to be a magnitude we want to find, which is x. We have this distance to be 180 minus 50, so that's 30. And we have this to be 40. All right, so using the Pythagoras theorem as we did for the previous one, x squared is equals to 30 squared plus 40 squared. X squared would be 2500, meaning the value of x, the square root of that is going to be 50. So that's going to be the magnitude for point 6. Now we need to find the angle, right? We have the opposite, we have the adjacent. You can use tan. So you can do tan of theta 2 is equal to the opposite, which is 40 over the adjacent, which is 30. So theta 2 is equals to tan inverse of 4 over 3. So theta 2 is 53.1301. And the that's the value of the angle is moving. Now, if you have to draw a coordinate system at this point, realize this is going to be the angle that you already have. So we don't need to add or subtract anything. So our magnitude in this case is going to be 50 at 50, and the angle is going to be 53.1301. Right, now let's go on to point 7. For point 7, the change in magnitude is 110 minus 40, and that's 17. All right, 17. And the angle is going up, which is 90. So 90 degrees. For point 8, the change in magnitude is 40. All right, 40. And the angle is in the 180 direction. 180 direction. All right, 180. For point 9, the change in magnitude is 40 because 150 minus 110, that's 40, and it's going upwards in the 90 degrees. So it's going to be 40, and the angle is 90. Now coming back to point 10, the magnitude is 60 because 100 minus 40, so at 60. And the angle is in the 120 direction. Sorry, 180 direction. So you go ahead and write 180. Right. So with this, you have been able to fill this table using the absolute and the relative in the polar coordinate system. Now, the next thing is to draw in AutoCAD using these values that we found. I'll see you in the next video where we actually draw this figure in AutoCAD using the points you calculated. Thank you for watching.